All right, guys, MF Mobile Lube here with old Caesar. What's up?
What's up?
2015 F-150 with a 3.5 liter. What's going on here is I had this vehicle brought in for an external coolant leak. It's still here 5 days later, so I'm fucking up. But the failure was an identical fitting to this on the opposite end of this turbo, and all this fitting does is it houses a few rubber O-rings that go ahead and hug the stamped steel line here, and that's what creates the seal. But it's a good opportunity to make a video about the basic turbo operation. This is your turbocharger assembly, starting from here to here. So what it does is the byproduct of any natural or any internal combustion engine is going to be exhaust gas, and that exhaust gas is expelled under pressure. So on a normal engine or a naturally aspirated engine, that exhaust gas is just going to be combined. The manifold, all it does is combine the exhaust gas from each individual port on the head, and it's going to just flow and plumb them out the back of the vehicle. When you put a turbocharger in between, what's going on is you're using that exhaust gas under pressure, and you're using it, utilizing it to spin a wheel. So your exhaust gas is being routed through here, and it hits a turbine here, and it turns the turbine, and you're talking tens of thousands of RPMs, and then it exits out the rear. Now there's a physical connection between the turbine in this housing and an impeller on this side. They consider this the cool side of the turbo, and here to here is the hot side of the turbo. Now there's no mixture as far as air or anything in here. It's just a mechanical connection. On this side you see the two ports. One of them is going to be a fresh air inlet. That's air coming past your engine air filter, comes through here. The impeller compresses it, and then it discharges it under pressure back into your intake. And the engine wants as much air as possible, as quick as possible, to burn as much fuel as possible, to create more horsepower. So that's the basic operation of a turbo. Now, if anybody's ever wondered the difference between a turbocharger and a supercharger, is turbocharger fans are going to tell you that since the exhaust gas is going to be exiting the engine anyway, they're utilizing waste and turning it into something useful as far as it spinning the impeller and doing its thing. Now on a supercharger, what it's going to need, the impeller is going to do the exact same thing, is charge air and force it into the engine. However, a supercharger uses the actual engine in order to turn this impeller, just like it was usually a belt driven setup. Think about an alternator or a power steering pump. So you're actually robbing a little bit of power from the engine to create more power, as with the turbocharger you're actually using the exhaust, which is going to be there anyway, and you're utilizing that to create more power. So if you're a turbo fan, you're making more power without taking any from the engine. If you're a supercharger fan, there's a lot less components that may fail, I guess fail points they would call it. So you don't have the hot, you're going to need to have it cooled, you're going to need to have it lubricated, you're going to need to have all these components, really tight tolerances, and the heat and expansion and whatnot. So supercharger fans, they say superchargers don't fail as often as turbos, and turbocharger fans say superchargers are counterproductive because you're using the engine to create more power. But regardless, that's pretty much how it works.